What we're going to cover today is really the need for real-time streaming. Why do we need to do it? And there's plenty of reasons. I'm going to come at it from an enterprise perspective, not so much the IoT perspective. And then, how do we go about consuming that data once we get it in? And then what are the use cases for it? What are the reasons we want to do it? What are the benefits we get out of doing it? And if there is time at the end, although I don't think we're going to get there, I can actually show you a demonstration of how you would do it using Kafka and bring it into a platform like memSQL. If not, the reason I still included it in there was you can look at the slides later on. It's pretty self-explanatory and shows you exactly how to do that. So, streaming is really about the continuous movement of data. It doesn't necessarily mean that my latency is in the nanosecond or the microsecond or even the second range. It could be, you could have a minute's worth of latency in there, but really it's all about the constant movement of data, right? Versus where you have batch or near real-time updates, micro batches, where the data comes in fits and bits, where you get these ups and downs, and you get periods within the data where access becomes difficult, right? So if I'm trying to update 100 million rows, I'm going to have significant locking on whatever my data persistence layer is, or I'm going to get data that's somewhat out of sync. So keeping that data constantly in motion keeps that as a flat line and doesn't impact your ability to consume that data. So when we talk about streaming, and I briefly mentioned this, but a lot of it is about the Internet of Things. So at DellEMC, we have data that's coming in from all of our storage arrays that are coming in from all of our servers, and we capture that data real time, and we're streaming that data real time into our data lake. And we do it more in batches, right? It's not really, streaming doesn't give us a whole lot. Right? We do stream it through some systems that look for alerts and reasons that we would want to go out and service our equipment out in the field. But the majority of the data that we have in our lake is really all about the analytics, looking for models, looking for common occurrences. And you're not going to get a lot of benefit of that from streaming that data into an analytical engine, right? It's really more trigger-based. But when you start to add in enterprise data, now I've got customer events that coincide with the alerts coming from the devices. I've got customers that I've got a salesperson going out to, and they've just created a Sev1 ticket. Well, that salesman needs to know about that Sev1 ticket. He can't know about it, an hour from now or 2 days from now. So the real benefit you get from streaming and the access to the ability to make decisions off of that data, the business value of it is in the enterprise data, and really gives us the opportunity to drive much better decisions much earlier in the process. So moving from batch to real time solves a lot of problems. I mean, it solves problems where we've got the data faster, we've got the data that's coming in real time so I can make real time decisions, but it also normalizes that data flow. If the data is constantly in movement, I don't have big windows every hour, every 24 hours, every 12 hours, where the database or the data platform is just completely busy. And therefore my user experience sometimes is good, sometimes isn't so good, and sometimes is unusable, right? It's a constant flow, it's very predictable. So why do we need the streaming data? Right, obviously we can use it for triggering events. That's, I think, fairly simple. We have use cases within our security organization where certain events that are happening from the firewall logs and the edge devices can trigger an event to happen. Can trigger someone going in, looking a little bit closer, can trigger shutting off certain segments. And that's interesting, and that's all streaming data. But to really get that value out, I need to add in that enterprise data. So for me, the vision is really to drive the Dell business toward a predictive enterprise using intelligent, data-driven agility. Right? I get the agility from the streaming, which will allow us to increase our revenues and productivity, and is really going to give us a competitive advantage against our competitors. So how do I do that? Well, I build more of an analytical enterprise. So I take all of this new data. Right, we've been taking these files that have been coming back from our systems for years and dumping it into an NFS drive. and then occasionally we would go look for diagnostic data there. Well, that's interesting, but it doesn't tell me that, hey, this particular drive model is going to fail in 3 weeks if I have certain conditions within the data center, right? So it's those longer term analytics that really helps us to gain a better insight. But that's all after the fact. That's learning about models that have occurred, last week, last month, last year. Excuse me. It's not about responding to what's going on today. So I've got all these new bits of data. I need to start bringing them in much faster, right? So my volume of data is going to grow rapidly. The variety and different types of data is going to grow very rapidly. And it's all going to come in very, very quick speeds. So how do I leverage that? I need to take these real-time, these streaming data sets in order to be able to make those faster, better decisions. But this can be very costly. If I'm using tools from, various third-party vendors that are very expensive, or I'm trying to scale up an old relational database, that's going to become a very expensive proposition. These things need to be very cost-effective. They need to scale linearly. I think that's why we're all here, right? These are big data sets that need to scale in low-cost commodity-type hardware. But that lets me put the data in the hands of the business, right? For me, our business users are very tech-savvy. So if I can get them access to that data in a low-cost, scalable environment, they can go crazy with it. They can find all kinds of information about it that I, as a technologist, wouldn't necessarily know. So let's take a look at an example. We have a system that basically goes and tries to figure out, well, which one of our customers is going to want to renew their subscriptions, renew their support. And this is a very time-consuming effort. The teams that are responsible for this did not have the ability to get to this data in a timely fashion. So the data was old. It was hours, days, months old. The accuracy of the data wasn't very good. So their ability to get those renewals was greatly hampered. What we ended up implementing and what the desired outcome was to get them this data in their hands as it happens. Right? Give them the customer service tickets, the customer current renewals, the contracts, the install base that they had. So when the sales folks went in there to sell them a renewal, they knew all the data bits about the customer. So in the past, it was a high-touch experience. There was a lot of people doing a lot of different things. There was a lot of data driven out of various silos, so that I wasn't able to get a good picture of what the customer looked like. If we move this to where we are in the future now, right, everything is self-service. Let's merge all the data together. Let's have the teams working together. So let's forget about the silos of data. Let's merge them into one silo and have all of the business units operating off that same silo. That's going to force the data quality. That's going to give them the increased productivity because they're not looking for data all over the place. This is the reason why we put all of our data into a data lake. And this really drives a lot more value out of the business. And in order to do this, we had to do a lot of steps in between, right? You can't just take all of your data, throw it into Hadoop and say, go at it, right? People aren't going to be able to realize the value of that data, right? It's one thing to take various logs and do a bunch of modeling on the logs and figure out some predictive analytics that you can run once in a while. It's another thing to take real-time data and actually do actionable intelligence on it. So this particular example that we're going to run through is the customer asset lifecycle management. So we take all of these bits of data that I've already mentioned over here on the left-hand side, we merge them all together with real-time feeds into a single data source, and we start running analytics on it right there and then as the data is flowing through. We can provide it as real-time data, real-time insight, as well as give each one of these customers a score. So a SEV1 ticket comes in, their score goes up because they're more likely to want to renew for that product, right? They haven't had any problems in 3 months, 6 months, a year. The likelihood that they're going to want to renew support for that product goes down, right? So we've got a real-time score that's running on that customer as events happen. And just to take a step back, all of this data has been brought together in our data lake. So I just want to spend a minute on this. This isn't really relevant to the topic other than the important part is that all of this data comes down here. We get it all into Hadoop. Well, that's great, but you can't really run real-time streaming of all these different sources into Hadoop and expect to be able to get real-time knowledge base out of it. Right? There are just certain limitations with the ability to merge all these different data sets real-time and still be able to present that in a quick fashion. So what we do is we take that data and we put it up here into an execution tier. Right? So we can do some denormalization of it in here in the process tier. Right? This is where we do some batch jobs, some batch loads. Install base doesn't change that frequently. Maybe it doesn't need to come in real time. But up here in the execution tier, this is where all of the real magic happens. It's where you can run your Tableau. It's where you can run your application written in Docker. It's where you can run your mobile app that gives the salesman up to the second information as they're walking into the customer site. Right? So we've got the foundation built. We push the data real time, and I'll show you how we do that shortly, into that execution tier, and we're able to provide it to the application, to the sales folks, to the end user in real-time fashion. So within this business question.
Could you elaborate a little bit on the micro batch?
So the question is, can I elaborate a little bit more on the micro batch? What do I mean by that? So we take real-time feeds, right? But we can't take a real-time feed into Hadoop. Now, yes, technically you can. You're going to keep a job thread open. So as I've got thousands of files coming into my Hadoop environment, if I've got a thread open for each one of them to try to stream in, I don't have any threads to actually do any work. So what we do is we batch it up. We leave it up on the queue for 5-10 minutes, sometimes a half an hour, and then we pull it down in one job. Right? So that's micro batching. It's like batch, but short periods. So how do we get this data into the data lake? So we ingest it, obviously, and we can ingest it, as you could have seen in the last slide, in batch. Comes in once a day, twice a day, every 15 minutes for a micro batch, or streaming. Right? So for streaming, let me just go back for a second. I can easily stream into an execution tier. Right? Gemfire is just an in-memory object store. MemSQL is an in-memory relational database. Postgres is a traditional relational database, and Cassandra, for those that you don't know, it's actually it's an object database but based off of columns. So it's really a column store database, not relational. It's relational-like, but it scales similarly to how Hadoop scales, right? Where bits of the data are stored throughout. They can all take real-time streams very easily. And then for the real-time analytics. So I mentioned about the triggering events, right? So I can tap off of a stream and I can look for certain events that I want to notify on. Well, that's interesting, and there's lots of different technologies you can do that in. We do it directly out of Stream. Stream's got a built-in library for doing those triggering events. And then there's real-time data insights and decision-making, right? So the customer score that I was talking about is real-time. Every event that comes in, it's going to recalc that score real-time and give that off to the business so that as I'm walking into the customer, I know exactly what their score looks like. Or maybe I wake up in the morning and I look, okay, well, what's my highest score? What's my most likely customer I'm going to win with today? And I can go visit them. And then we provide services to these mobile apps through APIs. So I can have an API that's running off of my Hadoop layer. I can have an API that's running off of my execution tier, my speed layer, for those of you familiar with Lambda. And those APIs could be what's the customer contacts for that day. We also use them for security. So sales reps are only allowed to see data for their customers. And so when they've got the API for customer, they're only going to see the customers that they're affiliated with. So to add real-time streaming into the lake, as I had mentioned, it's not really feasible to do it within Hadoop. It's not really feasible to do it within a lot of the big data structures. Cassandra is probably an exception to that. I've got to find a fast data platform, right? After all, that's what I do. I'm a data platform architect. And so I look at the different databases I've got out there. I looked at Oracle, Postgres, Cassandra, MemSQL, because I'm looking for a platform that is easy to deploy, that gives me some database agnostics, So I'm not worried about if I have to move from one platform to another, how much do I have to change, how much code do I have to change. I want to keep it as agnostic as possible, but I want to provide the ability to move to different speed layers. Different abilities, Postgres, open source, you can use it for free, no problem. It's got certain limitations, I'll kind of go through those in a minute. I can look at Cassandra, which scales linearly very well, but doesn't really work well in a relational format. I can look at MemSQL, which is an in-memory database, which is totally MySQL wireframe compatible, so I can take something that's running in Postgres, not meeting my SLAs, and literally just lift and shift over to MemSQL, and now I'm meeting all my SLAs. That lets me pick my real-time layer depending on the requirement. Right? It's going to depend on the velocity of the data, as well as the velocity of the consumption, as well as the size of the data. So I took a bunch of these databases, as I mentioned, Oracle, Postgres, SQL Server, which I hadn't mentioned because we didn't really go there, Cassandra, MemSQL. We benchmark and we find out, okay, what are the use cases that streaming will actually work really well in. And so we use this tool called HammerDB, and it was actually a friend of mine who actually wrote it, but it's very, very compatible with a lot of different platforms. So I can run the same benchmark on many different platforms. So I like to use it. I'm not going to drain through what the testing was. You can look at the slides later. But essentially we took the same workload and ran it against each platform. Right? Each one of these platforms, Oracle, SQL Server, and Postgres, we set up according to this is where it gets a little confusing. So Dell and EMC just merged. I came from the EMC side. So the EMC DBA standards, best practices for our data platforms, we applied them to each one of these databases, and we ran the testing. And the results were interesting. Oracle and SQL Server clearly were able to perform better, right, on the same hardware. But there's a high cost to those, and they're proprietary. So I took a look at Postgres and I said, that can really handle the majority of our needs. I can stream data into it very effectively, but that's not going to scale for me. So then we brought in-memory databases. We started testing a bunch of those in-memory databases. MemSQL was one of those. We took the exact same workloads that we were running in Postgres, ran them against MemSQL, and found the performance was just astronomical. And this was in essentially a 3-node cluster. Doesn't really work that way. It's leafs and aggregators, but there were 3 leaf nodes which held the data. We had copies of the data in 2 of the nodes. And so it scaled linearly and gave me some fantastic performance. And that's how we got that into the execution layer. So I'm almost done with the data lake and how we bring in data and stuff like that. We'll start talking about exactly once and why that's important. Yes?
How big is your MemSQL data store?
So for the use case that I was just showing you, we have 500 gig of data associated with that on the 3 nodes. Right?
Is it a column store or a row store?
Yes. It's both. So you can have a table that's column store, you can have a table that's row store. From consumption point of view, they look the same. It's really all about storage. The nice thing about the column store is I can spill to disk and really not get hurt significantly with performance, whereas the row store I need to store entirely up in memory.
So you guys use row store?
We have both.
Yeah, both.
Yeah, so we've got the majority of, or the variety of data is in the row store. We have one table that is fairly large, and we could shove it all up into memory, but I like to be economical, and so I let that one spill off the disk because there is older data in there.
Why not use more DB? Because it's already based on Postgres, already use Postgres. They are the same concept, right?
Not really. So actually, if I go back to the slide where I was testing the databases, Volt was one that I had tested. And if you write your package in Volt, so you write a package that does your data query in Volt, it's super fast. But I'm running like Tableau against it. I'm running other tools. My users are very SQL savvy, and as I had mentioned earlier, I wanted a platform that I could easily migrate workloads to, in and out of. Volt it's open source, but it's highly proprietary. Right, so it's good for use cases. There's certain use cases, but when I've got users that are writing apps against it, not so good. Okay, fair? There's a question?
Data write and data read conventions on these memory databases?
So each one has their own. The question is, what is the write and read contention on these databases? Or do you mean specifically on each one of the platforms?
I'm talking about that in-memory layer where you're bringing in the streaming data and also providing access data on top of it.
Yeah, so when you're streaming data, you can't have contention. And within MemSQL, there's no contention problems at all. In Postgres, I can run into a lot of contention problems. But as I had said, if I can fit in Postgres, it's free. Right? Nothing against the MemSQL folks in the room.
You have the next tier layer where you have the real-time task as well as the summary. Summary, I guess, this has a different slower, I use that term, velocity. That's how you play with the execution here, right? You're playing with two different flow speed, if I use that term, to render whatever operational service layer you want to do with the execution here. That's
Yeah.
what you have there.
Well, let me just hit the next couple slides because I think I answered your question there. And then if not, we'll try it again. So we take data in. As I had said, we wrote in Spring. So Spring has a lot of native libraries for ingesting data, which we make a lot of use of. You could literally use all kinds of different tools to ingest the data. The important thing really is that you need to be able to ingest the data in two multiple locations, multiple targets. Right, so Hadoop is obviously a default target. Everything should go to Hadoop. It's a very efficient way to store data. It's a very efficient way to run modeling programs against. But when you start getting into enterprise data and structured data sets, the meaning of the structure is important. I could just denormalize everything into one file, but then I have this massive data with all these duplicates in it, and it's really going to mess up my analytics. So I need to be able to bring that data into a real-time tier as well. Same examples that I had before, but we can do both, right? We can take that one piece of data, we can have multiple subscribers to that data, right? So it goes into Hadoop for analytics, for long-term profiling, but for all of my real-time needs and all the needs where I have an application running against it, I need to put it into a tier that can be consumed, right? And I understand that means I'm duplicating the data. And it's not just because I work for a storage company that doesn't matter. It's really, if you're going to get value out of the data, you're going to have to store it in more than one place, right? Because you need to consume it in different ways. Excuse me.
You're assuming that based on your showing summary going from the Hadoop layer, you're assuming that it's only summary data you need for your execution layer, which you have your real-time path. But you may have some raw data coming from the analytical data. So how do you deal when you have to have raw data going with the execution tier as well as your real-time path?
Okay.
That's what the customers want.
So the question is, how do I deal with data that has to flow through the analytical tier as well as mixing with some real-time data? So there's multiple ways of doing that. Lambda is a fairly popular way of doing it. I'm not a huge fan of Lambda. There are certainly times when you want to do it when you're doing big aggregate sets. Right, so if I'm taking 5, 6, 10, 20 tables and putting it into, say, a star schema or something like that, then it becomes very complicated to do it real time. You could run real-time ETL here, but as soon as you start running ETL, it's not so much real time anymore. So there are definitely times when Lambda works, right? And so I'll take a feed, and you'll see it actually. I should probably just go to those slides. So you'll see it in these data flows. Right, so we have 3 different data flows within that ingestion framework. We have the one time, right, very low velocity, and when I say one time, maybe it's once a week, or just one time only. Where I take the data, I throw it in a Hadoop, I might throw it into Greenplum depending on where my use case is and who's going to be consuming it. I may throw it into both. And I can obviously write data services off of that data. I really can't do a JDBC connection to Hadoop. I put the slide's a little bit old. The Pivotal HD doesn't really exist anymore. It's now Hortonworks. But I wouldn't really connect a JDBC driver to Hadoop, right? Unless I'm pulling from like a single Hive file. But generally my data is never that simple. You've got at least 10, 12 different objects within your data set. In which case, again, you got to put it really down here into a presentation tier. So the next one is batch. So these, would come in like micro batches more frequently than once a day or just once ever. And they're going to come in and they're basically going to append into Hadoop. They may append or merge into Greenplum. And then I may take that data. Because it's batch and not real time, I might as well run it through Hadoop, right? Because I don't need to put it to both. Especially when you have large volumes, you're talking about queuing, like you would in real time. So queues tend to go here to the speed layer. But when batch comes in, I don't want to have 100 million records on a queue. The queue will never perform. So I'd throw it into Hadoop, use Hadoop as my queue, and then I'll batch the updates into the presentation tiers. The one that we're here for, and the one that's much more interesting, is really the real time. Right? So real time could be very, very short micro batches, but it's really about streaming. Right? As data happens, we queue it up, we consume it immediately. And that has to go into a presentation tier. I couldn't put it into an MPP, relational database, massively parallel processing. I couldn't put it into Hadoop because as I'd said, I can't have an open thread for every single file that I've got running, plus all the garbage collection that I've got to do afterwards. It's just going to make that environment unusable. So I stream it right into a presentation tier to be consumed. Some of these presentation tiers obviously work better than others. The in-memory ones obviously consume a lot better, as well as present, but you do that at a price. Good. So let's really take a closer look at real time. Real time, again, to me is all about streaming, and you're really at the leading edge when it comes to real time. It's difficult in some cases to consume. A lot of the tools are coming along. Kafka's coming along, making it fairly easy to consume. Although the more easy it is to consume, the more you can get yourselves in trouble. And then we've got other vendors like memSQL, for instance, which make it really simple. You don't have to think about it. And you'll see that in the demonstration where you just literally subscribe to the Kafka queue, and you'll just always get it exactly once. Don't even have to worry about it. Trying to deal with always once can be complicated, right? Because somebody's got to figure out, did that message truly get sent and consumed, or did it just get sent and not consumed? Right? So we'll go briefly into what the semantics is for anyone who doesn't know what at most once, it's a little tricky to say, at least once and exactly once mean. Everyone up? So at most, when we talk about at most once, what that means is only one time. Never send it more than once. Right? So what happens is I dequeue from my message queue over here. I write it over here. I tell the queue I've consumed it, and then I save it. Right? So what could happen? Well, when I go to save it, it fails. This system goes down. But I've already told my queue, my source, I got it. So when that database comes back up, that data platform comes up, the app comes up, whatever, it's going to go, okay, well, I already sent you number 2, so I'm going to start at number 3. Over here, I've only got 1. Right, so that was close. I send it at most once. So there are problems, and I've got a chart in the next slides that tell me what those problems are. So at least once means I'm at least going to send it once. I might send it more. Right? In this case, I dequeue from the message, I persist it to my data store, I save it, and then I tell the queue I'm done. Right? So what could happen here? Right? I save it, everything's great, everything's working here. I go to say I got it, that fails, or the system goes down. So now I've sent it, at least once, but since he didn't know that I got it, I might send it again. So now I can have duplicates. So instead of missing the data, I may have more copies of the data for various reasons. Exactly once, what I'm doing is, not only am I sending the data, but I'm also sending the indicator, right, or the counter. So over here, I know which ones I got, and then when I go to dequeue, I only start, in this case, at number 1, I start at number 2. Right? The other example, which is much simpler, is over on this side. Instead of doing an append, I do an upsert. An upsert is an update or an insert, whichever is more appropriate. Right? But again, I need to know what this key is. Right? So over here, I'll know when I go to save it, I do an upsert, and within here it says, oh, you already got it. Ignore it. right? So I never get duplicates and I never miss any. So exactly once is where you want to go when you're talking about enterprise data. If you're talking about web logs and you miss a few logs, that's okay. You duplicate a few logs, that's okay. You're really looking for trending. But when you're talking about enterprise data, it's absolutely critical you get it only once. So I kind of covered some of these, but here, at most once, I'm only going to send it once. You didn't get it, that's your problem. You may or may not get it. You're definitely not going to get any duplicates, but you may be missing data. That's not good when it comes to customer orders. At least once, this one may be good for customer orders. You're going to send it at least once. You may send it more than once, but you're guaranteed to get the data. You probably have some duplicates. I'll take that sales order multiple times, that's helpful. The customer may not like it much. But I'm not going to be missing any data. I may double count some data, but I'm not missing any. With exactly once, you get everything you want. I get it once, I get it only once, everything's right, guaranteed. It's definitely the way you want to go.
What exactly once? Aren't you susceptible to building a huge queue up?
So the question is, with exactly once, aren't you susceptible to building up a huge queue? Are you suggesting because of the performance overhead of exactly once?
Yes, because that exactly once has to wait until it gets to the entire destination. So it's going to sit on the queue until that it gets to the final destination, whichever.
Yeah. So if you were single threading your queue, and you have a very, very high velocity queue, and let me go back, and you're pulling one record at a time, right? And you got to say, okay, well, did I get that one? Yes. Okay, go ahead. Give me the next one. And so you're basically almost doubling your processing. You can definitely run into that.
It's got to stay in sequence. I'm just saying it's got to sit there until the final destination.
Yep. So just because it has, so you're talking about strict ordering, just because it has to be in a strict order doesn't mean you can't multi-thread it, right? If you're doing it based off of ID, right? So I've had one thread that pulled this one ID. Since the DQ knows that I pulled it, right? Then the next thread is using that one, right? So as long as you stay within the same ID, you're good, and you can multi-thread it. So that's how you get past that performance problem. And then obviously, in order to get this data, in order to actually consume it, you need some sort of an application, right? Tableau is a fairly popular one. We use it a lot, and it can consume directly from a JDBC, ODBC connection. You can write a custom application using Cloud Foundry or Docker or D3. Those are all three pretty easy ways to stand up applications rapidly. Or there's many other third-party solutions. That's really not the important part. So everybody get the exactly once, at most once, kind of like once. We're good? How am I doing on time?
5.
5, good. Benefits that you're going to get, right? Obviously, if I've got all of my data stuck in its original source system, that's great. It's performing its ERP function or its CRM function, give me a yawn. But when I take all of the data in and I merge it together, I get benefits from that, right? I can do analytical processing, I can look for patterns, etc. But when I put this data into an execution tier that gives me the real-time data at real-time speeds, now I'm taking things that used to take people hours, right? So every single customer where they were trying to figure out whether or not, what their status of renewals were, somebody had to work 4 hours pulling all the data together, right? Every single quarter. Now, 1 minute a year, they just pull it up, they do a report. Or even better yet, they're taking it real time from their mobile app. Simplified provisioning, if I can get all of this data coming in real time in one place, I don't have to provision an environment for everybody that wants it. I can have one source of truth. I don't have all these different silos of data that different people controlling them. All of the data is where I want it. I literally could, I'm not actually doing this, but I literally could just drag and drop, give me my data sources. I'll get there, I'm not there yet. Keeping things database agnostic allows me to move between the right platform. If I've got a small velocity of data today, I could throw it out in any open source database, who cares? But as that velocity starts to grow, suddenly I've got this major replatform. But if I stay database agnostic, if I stay, say, MySQL wireframe compatible, I could move something easily from, Postgres to MemSQL to I could almost move it that simply to Cassandra. You move it to the data platform that provides you the performance that you need. So I have several examples here. I'm not really going to go through them, but basically where I'd showed a pyramid before and we talked about IoT and devices and how real-time streaming is interesting really more for triggering events. When I get into the enterprise data sets, now I'm talking about real value, right? That's why the bottom of the pyramid was so huge. We're literally talking, you're talking about device data. You're pulling in value sets of, say, $1 million, $2 million. You start getting into the enterprise space, you're pulling in values of hundreds of millions of dollars of revenue or cost avoidance. So specifically for this, and one of the things I think I want to make sure that you guys all walk away with is you're not going to do all of this in one day. And I would never suggest doing all of this in one project, right? You have a goal. Our goal for this customer asset lifecycle management tool is really to have everything at the fingertips of whoever needs it whenever they need it, right up to date. Well, it didn't start that way. We started by throwing it out into Greenplum. And that got us the 4 hours a quarter to 1 minute. So we were able to respond much faster. But as we move up the chain, now we're bringing it from an MPP database where I can run queries once in a while into an in-memory database, which allows me to pull the data whenever I want it with no performance impact or overhead. So that lets me make those decisions immediately. Right now, as I scale it out, I'm scaling it out to the sales folks and their mobile apps and giving the data right into the hands of the people that need it when they need it. And we're just going to keep going with this. But it didn't start trying to do real-time streaming day one. Let's get all the data in one place that I need, and then let's move it up the tiers into the hands of people that need it. And that's really, to me, the way to be really successful, to get it exactly right once. Play on words. And then we can take all kinds of things. We can start building data APIs so that, as I had said, my sales folks, regardless of what application it is, every single sales folk can only see the data about the customers they service. And that changes all the time. That changes several times a day. So those type of security APIs need to be kept up to date with that data as it streams in. 1 minute. So I'm gonna stop here. That if you go through the slides, this is an example of how to do it in MSQL, where you get that exactly once with almost no effort. And you can read through, it's pretty self-explanatory. The key here is the pipeline. So the pipeline lets you connect directly to a Kafka queue and consume off it, right? And this, what you'll see is the upsert is going to do that work for you, right? If the record's already there, good. If it's not there, then it's going to insert it. So we've got about 30 seconds. Any questions? Yes?
Question. So you talked about the real-time or exactly once concept, and what are the tools that have you done any comparison against? I think MemSQL is one we talked about, the Kafka, but is there any comparison against the various streaming tools that are available? And what is exactly once versus what does not support?
So all of the database platforms that I work with support the upsert concept, right? So like merge in Oracle, right?
I'm referring to more on a streaming platform, like
yep.
Whether it's the Kafka, whether it's the...
you could do it in RabbitMQ, right? Essentially Kafka's acting as your queuing mechanism, right? So you could use Rabbit, you could use can't remember who we used to use before Rabbit. You could use the Oracle Service Bus. Any messaging system you can stream from.
All right, I think our time's up. Thanks, Darryl.
Thank you very much.